Students, now if you remember that in last lecture we have seen one method for evaluating the limit of the function of the type here, that is limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a raised to n minus 1, where okay, now we have extended this result for the positive value of n, negative value of n, and a rational value of n. Okay, now here some functions are there in which this result is not useful. So which type of those functions and which results are useful in that case? So let us see here. If the function, that is the second method of evaluating limit of the function, is that the factorization method or method of factorization, isn't it? So here method of factorization. Now in this method what we have to do? That is, we have to find out the factors of the given polynomial functions. Now what is meant by polynomial functions? We will see it while solving the examples. Let us see, if there is a function f of x of this type, that is p of x upon q of x, where q of x is not equal to 0, or if these two both are polynomial of x, okay, then in this case whenever we want to find limit of the function x fx as x tends to a, then what we have to do here? So here very first we have to check the limit of the function vector. That is, if the limit of the function or polynomial q of x is equal to 0 at x is equal to a, then what happened? Then we cannot solve this example with the direct limit. So what to avoid this step? So its meaning is that there should be a factor, that is x minus a, in this polynomial, and this factor x minus a we have to remove from numerator and denominator if it is possible. But it is very sure, if limit of x tends to a is equal to q of x is equal to 0, then its factor is always there, that is x minus a. But if factor is not in p of x, then we cannot divide minus a to p of x. So here we have to consider other substitution, or in that case limit of the function x tends to a of f x does not exist when if this limit is equal to 0 and if in the numerator, that is p of x, then limit of the function does not exist. Remember this one. Okay, but if this is the one case, in second case, if the limit x tends to a of is equal to m, then our original function after limit, it becomes limit x tends to a of f x is equal to limit x tends to a of p of x upon only limit of numerator, denominator is m. And in this case, by taking now limit directly here, given function and find out the limit. This is the second case, if denominator is not equal to 0. Now third one, both the limits are 0, that is limit x tends to a of p of x is equal to 0, okay, and here limit x tends to a of q of a is that in both the polynomials the common factor is x minus a. Its meaning is that, I repeat it again, limit of denominator is 0 in both the polynomials, then its meaning is that there is a common factor x minus a in p of, then we have to find out that factor and cancel it from numerator and denominator, and then we can evaluate the limit of the remaining function and it will get exist and we have the answer. So this is the third one step, that is if we want to find out the limit, then we have to think about both the cases, that is denominator. So here to find out these common factors we can use factorization method in polynomials, okay. So there are different forms for finding the factors. By using synthetic division also we can find out the factor, okay. So see with the help of one example how to use this factorization method here to solve the example, isn't it? So let us see one more example there. Here we will take one example from exercise. Let us have, the question is that evaluate the, isn't it? Now here question number 1, and in that one sub question as limit z tends to 2 of z square minus 5z plus 6 upon here z square minus 4 bracket completed. Now to evaluate the limit of this function here, write down solution. Let us consider L is equal to limit z tends to 2 z square minus 5z plus 6 upon z square minus 4, okay. Now as I have told you, first we have to verify about the limit of the function of the denominator. So let us consider it. What is this one? Z tends to 2 of z square minus 4 and is equal to what? Here if we 2 z is equal to, then 2 square minus 4, that is 4 minus 4 is equal to 0. So obviously there is a factor z minus 2 in this term or in this polynomial. This is a polynomial of z, p of the numerator. So what about the numerator? That is again limit z tends to 2 here, and the function is that z square minus 5z, it is a polynomial of z having order 2. So substituting the value of z, that is 2 square minus 4 into 2 plus 6. So is equal to 2 square is 4 minus 5 into 2 10 plus 6. So you can see there 4 plus 6 10 Here numerator and denominator both have limit 0. Therefore, in numerator and denominator we have a common factor z minus 2, isn't it? So find out that factor by factorization method, cancel it and take the limit of the remaining term. So here we can write the function limit z tends to 2 bracket, and how to factorize it, you know this one. If there is a polynomial or minus 5z plus 6, then how to factorize it? Take the product of coefficient of z square and the last term, which is what? Which is 1 into 6, 6. Both are plus, therefore product is plus. Factorize 6 in such a way that the sum will be minus 5, product will be plus 6. So to get sum minus, both the terms should be minus, and to get product plus, both the terms should be minus or either plus. So how to here? If we take the factors of 6, there are only two factors, 3 into 2. So if both are negative, then and then their sum is negative and their product is positive. So the factors of z square minus 5z plus 6 are z into z minus 2, isn't it? So here we can write the factors as z minus 3 into z minus 2. And if you look at the denominator, then obviously denominator is z square minus 4, that is a square minus b square, because 4 is also a complete square, that is 4 is equal to 2 square. Therefore here z square minus 4 means z square minus 2 square, that is z minus 2 into z plus 2. Okay, hence by using the identity, that is a square minus b square is equal to a minus b into a plus b. Therefore we get the factors like this one, bracket completed. So here one common factor you can find there, you can see it is very clear and obvious. This one is the common, so cancel from numerator and denominator. And if you look at the remaining factors, okay, and especially at the denominator there is z plus 2, and if we substitute z is equal to 2, then 2 plus 2 becomes 4, that is denominator is not going to become 0. That's why here we can take directly the limit of the remaining terms, but before that collect first the remaining terms are there in numerator z minus 3 and in denominator z plus 2, isn't it? So here by substituting the value of z, that is taking limit, we get 2 minus 3 upon 2 plus 2, that is 2 minus 3 is equal to minus 1 by 2 plus 2 4. Hence finally we get that L is equal to, that is our required limit is minus 1 by 4, isn't it? So this is about the factorization method, that is how to evaluate the factors and then how to evaluate the limit by using factorization method. This is one example. So let us see one more example there. We can see one more example here, and then we can find out the limit of the other function also. So let us have there limit u tends to 1. Okay students, in previous slide we have seen the factorization method. Now we will solve some examples depending on the factorization method. So let us see here how to solve the examples. More examples. Now here evaluate the following limits, and the first example is that limit x tends to 1 u raised to 4 minus 1 upon u cube minus 1, isn't it? So here to solve this example or to find out the limit of this function by using factorization method, first we have to write the given function in standard form as, so write on the solution. Let us have a solution. Let L is equal to limit x tends to 1 u raised to 4 minus 1 by u cube minus 1 is equal to limit x tends to 1. This function can be written as u raised to 4 minus 1 raised to 4 upon u cube minus 1 cube is equal to limit x tends to 1 and u raised to 4 minus 1 raised to 4. This function can be written as here u square minus 1 square and into other bracket u square plus 1 square, just like a square minus b square, and u cube minus 1 cube by using the formula u minus 1 u square plus u plus 1. So is equal to limit x tends to 1, again u square minus 1 square upon okay, and here to expand this we used a formula a cube minus b cube is equal to a minus b a square b square. You know this one, and for the numerator we have used this identity a minus b into a plus b. Here the common factor get cancelled and we can write here limit and here the variable is u, therefore we have to write limit u tends to 1, that is the common factor u minus 1 we have to cancel from numerator and denominator. Therefore here we get the remaining terms are u plus 1 u square plus 1 by plus 1. Okay, now here there is no term in the denominator, due to which denominator will become 0. That's why we can take a direct limit. Okay, so limit u tends to 1, that is there is no need to write it again, we can directly substitute the value of u plus 1 1 square plus 1 by 1 square plus 1 plus 1, that is 1 plus 1 2 into 1 square is 1 again and again 1 plus 1 2 by 1 square is 1, that is 4 by 3. Therefore our required limit L is equal to 4 by 3. This is our required answer. And let us see again how to solve it, why we need to factorize it. If we directly substitute the limit, then we get 1 raised to 4, that is again 1, that is 1 minus 1, and at the denominator also 1 minus 1, that is it reduces to the form 0 by 0. And if we get this form, then you must know, that is you should get that here we have to find out that common factor u minus 1 in numerator and denominator. So find out this factor and cancel it. Okay, so Here we have find out it by factorizing the given terms, the polynomials, and we cancel it in this way here, and by substituting the limit we get the required answer, that is L is equal to 4/3. So this is about the factorization method. One example we solve it. Let us see one more example. Here again the question is same, evaluate the limit of the following: x tends to 3, and here 1 by x minus 3, 1 by x minus 3 minus 9x by x cube minus 27. Okay. Now to evaluate the limit of these functions, let us consider solution. Let बघत होते काहीतरी आहे लिमिट ऑफ मेथड ऑफ करूया ना ते
त्याला कंटिन्यू करतात मी आल्यानंतर करते बाकी इच्छा
म्हणजे तू सेपरेट बनवू शकशील का बर मग आता हे मिटू दे ना एकदा
किती पुढे आणि तू मग पेज ऍड करून देऊ
ह्याच्यामध्ये नाही पुष्कळ होतील तेवढे
त्याचे एक्झाम्पल पण घ्यावं लागेल ना तुम्हाला एक्झाम्पल आणि त्या पॉईंट एक स्लाइड होते
हे काही इथे ऍड पेज आहे ना
हा
तिथून घेते करून बघू का तुझ्या देखतच एकदा कुठं झालाय हा दोन नंबरला आलेली करू का सुरू आता जवळजवळ 3 मिनिटाचं रेकॉर्डिंग झालं
तुम्ही आता फक्त रॅशनलायझेशन आणि त्याचे एक्झाम्पल घ्या रुटीन आणि मग बंद करून
होय रॅशनलायझेशनचं सेपरेट बनवणार आहे ना ते ह्याच्यात नाही ना
नंतर करते
हा पण सेपरेट राहील ना ते कारण हे ग्रुप होईल
एक्झाम्पल सेपरेट
बर चालेल
आता पुढचे प्रत्येक पॉईंटचे आपण एक व्हिडिओ बनवणार
अच्छा बर 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 चालेल सुरू करते मी आता हे बरंच आले जवळजवळ 3 मिनिटाचं झालंय आता इथं उजेडचं काहीतरी केलं पाहिजे रे अक्षय हो हो let us consider the given function limit x tends to 3 here 1 by x minus 3 minus 9x upon x cube minus 27 is equal to limit x tends to 3 here, okay, and 1 by x minus 3, okay, minus 9x, and here you can see this term is factorable. So factorize it and we can get the factors as x minus 3 x square plus 3x plus 3 square, that is 9. Okay, so we get one common factor, that is x minus 3. So multiply for the similarization of the denominator, x square plus 3x plus 9, okay, and minus 9x, because here there is no need to multiply this numerator by any number. Now here collectively the common denominator now becomes x square plus 3x plus 9 is equal to limit x tends to 3, okay, and here we can have x square, okay, 3x minus 9x, that is minus 6x plus 9 upon x minus 3 into x square plus 3x plus 9, like this one. Now the numerator is factorable, so to factorize it, let us consider limit x tends to 3 here, and the factors will be x square minus 3x minus 3x plus 9 upon x minus 3 x square plus 3x plus 9, okay. So here we get the factors as limit x tends to 3 in bracket x minus 3 and again x minus 3 upon x minus 3 x square plus 3x plus 9 bracket complete is equal to limit x tends to 3. Here this common factor get cancelled and collect the remaining factors, x minus 3 x square plus 3x plus 9. Now if you look at the denominator, then there is no term due to which the denominator becomes 0. So taking limit directly, 3 minus 3 upon 3 square plus 3 into 3 plus 9. Now 3 minus 3 is 0, 3 square 9, 3 into 3 9 plus 9, that is 0 by 27, that is 0. Hence our required limit is 0. Okay, so in this way also we can solve the examples, isn't it? Now let us have one more example, that is here limit y tends to half into bracket 1 minus 8y cube by y minus 4y cube, okay. Now how to evaluate this limit? We can evaluate this limit in this way. So let us have a solution. Let us see how to evaluate it. Let L is equal to limit y tends to half in bracket 1 minus 8y cube by y minus 4y cube. Okay. Now here limit y tends to half, this term can be written as 1 minus taking y common 1 minus 4y square. So is equal to limit y tends to half inside the bracket, this term can be written as, that is, and here y into 1 minus 2y bracket square, and this term 1 square. Okay, bracket complete. Now here if you look at this term, if we substitute the value of y as half, then 2 get cancelled, 1 cube, that is it becomes 0, and for the denominator also 1 minus 2 into half, again 1, and 1 square, that is again it becomes 0. So this is of the form 0 by 0. Okay, so to avoid this one, we have to find out the common factor, that is y minus half or 2y minus 1, and if we remove this factor, then we get the limit. So for that purpose we have to factorize it by using factorization. So E is equal to, therefore let us consider L is equal to limit y tends to half inside the bracket 1 cube, that is 1 minus 2y, then 1 square plus 1 into 2y, and plus 2y square, that is 4y. 4y square upon y into 1 square minus 2y, that is a square minus b square, that is a minus b means 1 minus 2y, and a plus b, that is 1 plus 2y bracket complete. So is equal to limit y tends to half in bracket, isn't it? And the remaining terms are 1 plus 2y plus 4y square upon y into 1 plus 2y, like this one. Now here we can now substitute the direct limit here, 1 plus 2 into half plus 4 into half square by half into 1 plus 2 into half is equal to 1 plus 1 plus 4 into 1 by 4, okay, and half into 1 plus again 1, that is 1 plus 1 plus 1 upon half into 2, that is equal to here is equal to 3 by 2 get again cancelled 1, that is 3. Therefore our required limit is L is equal to 3, isn't it? So in this way you can solve the remaining examples also, and it will be very easy. You can use if according to the conditions, synthetic division also. There are some solved examples are also given for solving synthetic examples by using synthetic division method. Due to the time limit I cannot take it, but you can follow our textbook on page number 140. One example is given there. in which synthetic division is used. Okay, and we use synthetic division wherever uh, if we cannot find the factors very easily. Okay, then by synthetic division we have to factorize the given polynomial. So follow that one and you will get there, you will get that. Okay, so enjoy the lecture and have a good day.